Good morning, guys. Happy Monday. Welcome to today's lesson, April 27th, Add and Subtract Monomials. We are now in the Algebra 2 folder, which is right below Module 5. So make sure at some point today, right before you start working, make an Algebra 2 folder or just copy over the section. Sometimes it doesn't work when you copy over the section, but you can very simply just in the bottom left of the screen right now, hit Add Section and call it Algebra 2. So this is a good opportunity, a lot of good Algebra 2 prep. So you walk in next year and everything isn't so new, and I know algebra was a long time ago. You'll be in a good place headed into, your Algebra 2 year. Alright, so let's take a look at the do now. First of all, our aim. How do we add and subtract monomials? So what is a monomial? It's basically just a polynomial, which is really an expression in math that has one term. Alright, so if you see number 1, 5 plus 2. Of course, we know that 5 plus 2 is equal to 7. Right? But then with something like number 2, 5x plus 2x, alright, how would that change the answer? Alright, that would be 7x. Not 7x squared or anything like that. It's literally the same thing, guys. It's 5 plus 2, which is 7, and then the x comes along for the ride. And we'll talk about sort of like what are the rules with adding and subtracting right after this do now. Alright, next, we have 5x cubed, or to the third power, so 5x to the third, y to the fourth, plus 2x to the third, y to the fourth. So if you notice, once again, we have the exact same variable and exponents in each of the terms, in each of the monomials. Alright, so once again, this would be 7, and then the variables with their respective exponents come along for the ride. So it would be 7x to the third, y to the fourth. Alright. Now the next one, 5x to the third, y to the fourth, plus 2x to the third, y to the seventh. Now these, alright, they both have that x to the third in common, but they do not have that y value. They both have a y variable, however, with a different exponent. That actually means that they're not like terms and cannot be combined whatsoever. Because they have two variables, they're both part of the expression. Alright, so it makes them not like terms, so honestly, it's just, you would rewrite it. Alright, it would say to simplify would be your directions, and you can't simplify. It's sort of like a trick question. Once again, because of the fact of the matter is that they do not have the same exponent, alright, for that y value. Okay, we have y to the fourth and y to the seventh, no good. Alright, now which was the most difficult for you? Alright, it could have been number 3, it could have been number 4. Potentially number 4 you might have got tricked on if you actually tried the do now first before we go over it. Alright, but number 4 is the trick because those are not like terms. Okay, so math is all about rules, right? Know your rules and you'll do well. What is the rule for adding and subtracting? So what we need to do, we need to look for like terms. Now what are like terms? Like terms are terms that have the same variable or variables. It could be multiple. Alright, and also, as you saw in that number 4 in the do now, and exponents as well. Exponent or exponents. If two or more terms are like terms, we can combine them by simply adding the what. So it's basically those numbers that are in front of the variable with the exponent and all that. Those are called coefficients. But I know you'll be thinking of them as, alright, it's just the number in front, and that's fine. So number 1 here says, if you can do 5 plus 3, you can do this next one. It looks a lot more challenging. You know 5 plus 3 is 8. Alright, but now, in number 1 here, it looks all weird because it has, on the end here of the 5, x to the third, y to the fourth, and z. So ask yourself, does the other monomial, that other term there, also have those same variables and exponents? So it has x to the third, yep, y to the fourth, yep, and z, which z right now is to the first power. But regardless, you end up with 5 plus 3, those are the numbers in front, the coefficients, that's 8, and then all those variables with their exponents come along for the ride. It would be like if I had 5 apples and then I was adding 3 apples, right? I would have 8 apples in total. All right, so that whatever it's basically like characterized by, like with those variables and exponents, those just come along. All right, so number 1, 6x to the 4th plus 3x to the 4th. All right, so they are like terms. They both have x for a variable, and they have the same exponent of 4. So you just add the numbers in front. 6 and 3, right, is 9, and then the variable and the exponent come along for the ride. Number 2 here, 6xy plus 3x. Now, both the 6 and the 3, they both have an x. However, the 6 also has a y with it, and the 3 does not. So they have to literally have the exact same variables and the exact same exponents. In this case, the 3, the second monomial there, the 3 does not have a y. These are not considered like terms. So if you were asked to simplify it, you would literally just rewrite it. Right? Those are not like terms. They have to have the exact same thing like before. Right? Here, they all have x to the 3rd, y to the 4th, and z. Here, one of them has xy, the other one has x, not like terms. Okay? So you can only combine the like terms. Other terms are simply just brought down. All right? All right, let's keep it moving. So now we have a couple different things here. Number 3, we have 5x plus 7 minus 2x. All right, so we have a few different terms. So 5x. Are there any other terms that also have x? Right, that also have x for their variable, and that's x to the 1st power. All right, you see that 2x there, but it's really a minus 2x. All right, you keep the sign in front. That's something very important in this. All right, if there's a negative sign in front, make sure you keep that with it. So those are like terms. And then also we have 7 and we have 12. Those are called constants. Those are numbers that do not have, right? They don't actually have a variable. They're just a number by itself. Those constants are also like terms with each other. So now sometimes you don't have to do this every time, but as we get started with stuff like this, you should write the like terms next to each other, so we're kind of just rearranging the expression. So 5x and minus 2x, those are the like terms. And then we also have 7 and we have 12. So you combine your like terms, 5x minus 2x, that's 3x. And then 7 plus 12 is 19. It'd be plus 19, and that would be your final answer. So we only combined the like terms. All right, number 4 here. So 3x squared. You see any like terms with 3x squared? Any of the terms here have an x squared? The answer is no. So 3x squared does not have any like terms. All right. Now, so I'm going to change colors. 7x, does that have any like terms? Hopefully you're thinking minus 4x, not 4x, minus 4x. And then we also have constants, -1 and 6. I like to do different colors for the different like terms. So I'm going to write them next to each other. 3x squared plus 7x minus 4x, because the x's are like term together, right? -1 plus 6. So 3x squared, just like we wrote before, other terms are simply brought down. 3x squared is brought down because it doesn't have any like terms with anything. All right. Now 7x minus 4x, those are like terms. That makes 3x. And then -1 plus 6. Guys, don't get caught up in your integer rules. If you know your integer rules, that is tremendous. Okay, but if you don't know what -1 plus 6 is, which you might not, it's okay. You can simply type that in your calculator. I know it seems like very elementary school, but look, you don't want to make a silly mistake. If you don't know what it is, that's fine. Type it in. -1 plus 6 is 5. And you're done. All Alright, remember at any point you can stop the video. I'm going to go through everything together today because this is our first lesson of Algebra 2. But if you want to pause the video, try it out on your own, absolutely. So now 5xy. So we have to look for other terms that also have xy. We have a plus xy there. By the way, what's in front of that xy? We have a 1. If you don't see a coefficient, if you don't see a number in front, that value, it's like an invisible 1 there. Alright, next, negative 7y, not 7y, negative 7y. Alright, any other y terms? Nope, nothing has just y. And then also you have 2x. So I'm not going to rewrite this out, but your green terms here, the underline in green, 5xy plus 1xy gives you 6xy. And then the other terms are simply brought down. In any order, it doesn't matter. You could write negative 7y plus 2x. Those can't combine with anything. They don't have any other like terms. But you could have written it as 6xy plus 2x minus 7y. Alright, the order does not necessarily matter. Alright, next, 7xy squared plus 4xy squared, 4x squared y plus 6xy squared. So the first term here, 7xy squared, is there another term that has xy squared? There is. There's a 6xy squared. Now the 4x squared y, alright, even as I read that, it slipped me up a little bit, so it's a little bit like, is it the same, is it not? It's different because the x is to the second power. We have an x squared and a y to the first power, and that's not the same for the other terms. That would be x with y squared. So combine your like terms, 7xy squared plus 6xy squared. It's basically just 7 plus 6, alright, which is 13. And remember that xy squared comes with it. And then the other term that has no like terms with it just gets brought down. So plus 4x squared y. That's it. Alright, a couple more. Alright, this one's different, right? So a general rule, guys, I used to teach 7th grade. Alright, whenever you see parentheses or really a number in front of parentheses like that, that means we're distributing. Alright, the distributive property. Almost always, and I can't say this is 100% of the time, but almost all the time, if you see an opportunity to distribute in a given expression or equation or something like that, you do that first. Alright, first step, you want to distribute if you see that opportunity. So that 3 in front is getting distributed to everything that's inside the parentheses. So now we're talking multiplication. Right? So 3 times 2x. What's 3 times 2x? Now you can multiply unlike terms. So these 3 and 2x, if I said to add those, you can't add them. Alright, but you're multiplying. You can multiply and divide unlike terms. You cannot add and subtract them. Alright, so 3 times 2x is what? What's 3 times 2x? 3 times 2 is 6, and then the x comes along, so it would be 6x. Alright, and then 3 times 6, a positive 6, right, is 18, so this would be plus 18. And then you still have that minus 5x at the end. We don't multiply by that minus 5x because that wasn't in the parentheses. Your like terms are 6x and negative 5x. 18 doesn't have any like terms with it, but combine those like terms now. 6x minus 5x is 1x, which should just be written as x. You could write the 1 in front if you'd like. Alright, so it would be x plus 18. So a rule here, kind of another rule. If you see an opportunity to distribute, do that. Alright, now 2x to the 9th, y to the 3rd, minus 7x to the 9th, y to the 3rd. These are like terms. They both have x to the 9th, y to the 3rd. So that's what's going to be brought down essentially. Alright, but remember the coefficients, the numbers in front, are what we have to handle. So it's really saying we need to know what's 2 minus 7. Those are the coefficients, the numbers in front, that's what we have to take care of. I'll talk about the integer rule. Guys, put it in the calculator if you don't know it. But that's really 2 plus -7. When you see subtraction, you add the opposite. And now you have more negatives than you do positive. You have 5 more negatives than you do positives. Okay, not overly important. All right, 2 minus 7, you can chuck that in the calculator. 2 minus 7 is -5. But it would be -5, and then you keep the x to the 9th and the y to the 3rd. All right. And one more. You have some a terms, some b terms, some c terms. So we have 6a. We have, what's the like terms with that? No, we have 9a. And we have, please don't say 3a. I know I'm picturing myself calling on you right now and saying the terms. And you could be like, all right, 6a, 9a, 3a. No, it's not 3a. It's -3a. All right, so now we have also 4b. What's the like term with that? We got 8b with that. And our c terms, -5c, -4c, and 11c. This is absolutely one of those times where you should rewrite the terms next to each other. Just a little easier to see, but it would be 6a minus 3a. I'm going to write the b terms together, plus 4b, plus 8b, minus 5c, minus 4c, plus 11c. These were your ones in green, right? These are your ones in blue, and these are your ones here, just to show you where that's coming from. So we're just writing the like terms next to each other. Now 6a minus 3a, you know that, 6 minus 3, 3a. 4b, positive, right, plus 8b. 4 and 8, you know that, right? Plus 12, plus 12b. Now the next one, -5c minus 4c plus 11c. Definitely it might slip you up. That's totally fine. Throw it in the calculator. That is fine. Do not be ashamed of that. It's -5 minus 4 plus 11. And you see it ends up as 2. So we don't know it. It's fine. Throw it in the calculator. So it'll be plus 2c. And we're done. So the big idea here, guys, this is great for Algebra 2. All right, we wouldn't have had this opportunity if it was, we were still in the actual building right now. We'd be prepping for the regions and all that. We can take a step back and actually look at these problems and get you a good head start for the Algebra 2 year. So make sure you're doing the right thing so that you do indeed move along to Algebra 2. All right, the big idea for the lesson, we can only combine like terms. When we're adding and we're subtracting, we only combine like terms. What is a like term? Right? It has to have the same variable and the same exponent. And then you just add the numbers in front, those coefficients. All right, so you can look through these problems. Your Delta Math will be posted later on today. You can get a head start on that as well. That'll be due Thursday at 8. And that is it. Have a wonderful rest of your day, and I'll see you mañana.